us to talk about some properties of functions. I keep thinking we're going to look at the visual graphs of these functions, but not yet. That's closer to the end. I want to talk about some properties that functions can take on. So the first thing I want to talk about is an even function. Functions are even if and only if, whenever the point xy is on the graph, the point negative xy is also on the graph. So if I have a graph like that is even, it's going to be symmetrical about the y-axis. So here are some graphs that are symmetrical about the y-axis. We have the function when y equals 1. We have the absolute value function, right? Absolute value graphs every point to its distance from the origin. We've got our cosine function. That's a trig problem. I don't think we have to worry about that in this class. We've got our nice little parabola, okay? And so all of these functions are even. A function is odd if and only if, whenever the point xy is on the graph, the point negative x negative y is also on the graph, okay? That means our graph is symmetrical about the origin. A good example of that is y equals x, okay? If the point 1, 1 is on our graph, the point negative 1 is on our graph as well. So in order to identify even and odd functions, we're going to be substituting in negative x for x. If I find that when I substitute in negative x, I get f of x unchanged back out, the function is even. If I plug in negative x and I get negative f of x, so the negative of our original function out, then our function is odd. So for this first function, I have f of x equals x squared minus 5. We're going to substitute in negative x, and that gives me negative x squared minus 5, which simplifies to x squared minus 5. So f of negative x is equivalent to f of x. This means my function is even. It's important to note that not all functions are even and odd. Some are neither. Let's take a look at f of x equals x cubed minus x. If I plug in negative x, I get negative x cubed minus 1. That gives me f of negative x equals negative x cubed minus 1. Notice that this is not f of x. Sorry, this is not f of x. But it's also not the negative f of x. If I wanted negative f of x, that would be negative x cubed plus 1. So this is an example of neither. Okay, last but not least, I'm going to plug in negative x into 5, x cubed minus x. So I get f of negative x equals negative 5x cubed plus x. This is not f of x, so it's not even, but it is the negative of f of x. So this function is odd. Another thing we can tell from looking at the graphs of functions is where they are increasing, decreasing, or constant. So let's label a function when it's increasing, it's going to look like it's going uphill. Decreasing, it's going to look like it's going downhill, and see where it's constant. So this is 1, 2, 3, 4, 5. Okay, so it's counting by ones. So from the interval when x is 7, negative 7 to 6, 5, 4, negative 4, okay, on this interval is where my function is decreasing. So our function is decreasing on the interval from negative 7 to 4. Our function is going to be increasing. So here it's decreasing. Here it's going to be increasing from negative 4 to negative 3. It's constant from -3 to 0. Constant from -3 to 0. Let's label that with a C. Next, I'm going to take a look here. Okay, so my function's decreasing. It still looks like it's going downhill from 0 to +1. Then it appears to be increasing from 0 to 5. So I'm just labeling all these intervals. Then it's decreasing again from 5 to 8. So here it was increasing, here it's decreasing. And then we have it increasing again from 5 to 12. Functions can have local maximums and local minimums over an interval if f of x is the largest point for that x on our given interval. So for here, our local max is here, and our local min, we've got another local max. You can have multiple local maximum and minimum. Absolute minimum and absolute value are a little bit different. Absolute minimum is going to be the smallest number on the entire graph. These are sometimes called absolute extrema or extreme values. And the absolute minimum is going to be our smallest value on our graph. The last thing we're going to talk about in this section is rate of change. So if y equals f of x, the average rate of change from a to b is going to be the difference in y over the difference in x. Okay, let's say that again. The difference in y over the difference in x. So if I want to find the average rate of change from 1 to 3, I'm going to look at the change in y over the change in x. So I'm going to take 3 of, so here's my a and here's my b. 3 of 3 squared minus 3 of 1 squared over 3 minus 1. This would give me 3 squared, which is 9, times 3, which is 27. 27 minus 3 over 2. That would give me 24 halves, which is 12. Maybe I shouldn't use blue. 12. If I want to look at the average rate of change from 1 to 5, I'm going to look at the change in y over the change in x. So I went 3 times 5 squared minus 3 times 1 squared over 5 minus 1. That's going to give us a denominator of 4. 5 squared is 25, so I have 75 minus 3. That's going to be 72 divided by 4. Which is 18. Next, if I look at the average rate of change from 1 to 7, I'm going to look at the change in y, the change in x. Let's change colors because posterity. 3 times 7 squared minus 3 times 1 over 7 minus 1 gives me a denominator of 6. 7 squared is 49 times 3 is 147 minus 3 gives me 144 divided by 6 is 24.